Hi, hello. This is Yashas M. I'm a computer science artificial intelligence student studying in Sri Venkateswara College of Engineering. Today I am going to present a presentation on the process management in operating system. For first, I'm going to discuss about the topics and aims of this presentation. Welcome to our presentation on process management in operating system. Our goal is to explain the basic concepts and terminology of the topic, as well as provide an overview of types of process, process states, and process scheduling algorithms. What is process management? Process management is a key function of operating system that ensures the efficient execution of programs. It involves creating, controlling, and monitoring the execution of processes and allocating system resources such as memory, CPU time, and input-output devices. In essence, process management is responsible for making sure that programs are executed correctly and efficiently. Applications. Applications are programs that are run by a user, such as word processors, web browsers, and games, and the external apps, which have been used for the user specified task. These programs need to be able to run concurrently with the other programs. System software. System software consists of programs that provide a platform for other software to run. Examples include device drivers, system utilities, and security softwares. Now let us go to the operations. Operations are the day-to-day tasks that an operating system performs, such as managing memory usage, disk space, etc. Types of processors. First, these are being categorized into two main branches: the system processors and the background processors. Later, these are being subdivided into user processors, foreground processors. First, let us come move to the user processors. The user processors are created and managed by the user. These are usually programs that user runs, such as text editor or a media player. Comes the system processors. System processors are created and managed by the operating system. They provide essential services to the user and other programs, such as managing memory or processing network data. Now, foreground processors. The foreground processors are those that require user interaction, such as web browser or a text editor. They are given a higher priority by the operating system to ensure a smooth user experience. Background processes are those that run without user interaction, such as system maintenance, task, or file backup. These are given a lower priority by the operating system to ensure the foreground processes have enough resources to run smoothly. The processor state. A processor goes through different states during its execution. Understanding these states is essential for understanding how an operating system manages processes. Ready. A process is in ready state when it's waiting to be assigned to a processor. Running. A process is in the running state when it is waiting to be processed by the processor. Now let us move to the process control block, PCB. The process control block is a data structure used by the operating system to store information about a process. It contains essential data such as process ID, state, process priority, and CPU scheduling information. Process ID. An unique identifier assigned by an operating system to each process state. The current state of the process, such as running, ready, or blocked. Process priority. A number assigned by the operating system that determines the relative importance of the process. CPU scheduling information. The information about the schedule processor time for the processor. Process scheduling algorithm. The process scheduling algorithms are those used by the operating system to manage the allocation of CPU time to process. Different algorithms prioritize different aspects of the system such as fairness, responsiveness, or throughput. Round robin. A scheduling technique in which each process is given a fixed time quantum to execute before being preempted and moved to the back of the queue. Priority scheduling. A scheduling technique in which processes are assigned a priority level based on their importance and their scheduler always selects the process with the highest priority for execution. A scheduling technique in which the process with the shortest estimated CPU time is selected for the execution. Next. Inter-process communication (IPC) allows processes to share data and synchronize their actions. Different methods of IPC are used by the operating system depending on the nature of the process and the data being shared. An unidirectional communication channel between the two processes. One process writes to the pipe and the other reads from it. A communication method in which process can send and receive the messages to and from other processes, as we can observe from the above following diagrams. Process synchronization. Process synchronization is the process of coordinating the execution of multiple processes to ensure that they do not interfere with each other. It's essential for preventing race conditions and deadlock. First, okay, these are being categorized into three types: locks, atomic operations, and semaphores. Locks are synchronization mechanism that allows process to acquire exclusive access to the resource. In atomic operations, an operation that is executed as a single, indivisible step, preventing other processes from interfering with it. Semaphores, a synchronization primitive. Okay, at last we come here, okay, to the conclusion. Okay, from this we can conclude that the process management is a critical function of an operating system. By managing processes, the operating system can ensure that the resources are used efficiently and the system remains stable. In addition, process management allows the operating system to control how programs interact with each other. This article has explained how process management, different states of the process, and context switching. Okay, I like to end my presentation with a thank you note.